Yeah, hi everyone. So in this session, I'm going to um, cover BGP lab topology um, with uh, Genus 3. So I have taken router 7000 series for configure this topology. Okay, so let me take the mouse also. Just give me a second. Fine. So Yeah, so let me explain about this topology. So this is R1 router, R2, R3. These are configured in IBGP in single autonomous, like autonomous 1 to 3. And R5 is in autonomous 500. So you can just remember like R5 is in 500, R4 is in 400 autonomous system, R7 is 700 autonomous systems, R6 is in 600 autonomous systems. So coming to the IP yeah, I configured as you can see 1 to 2. I have taken 192.1.1.12.0/24. Okay, so here in router 1 it should be 192.1.12.1, and here in router 2 192.1.12.2. So this is the way I have configured the IP address on the interfaces. You can check in R1 R4 like it should be like 192.1.214.0/24. So 14.1 is at router 1 and 14.4 at router 4. In similar way, I have configured all the interfaces. You want uh, in between R1 and R7 it should be R17/24, and let me configure in between R4 to R7 as it should be 4/7, and in between R6 to R7 6/7.0, and in between 3 to 6 it should be 3/6.0, and in between 3 to 7 it should be 3/7.0. Okay, so this is the IP address have been configured on the interfaces. Okay, so yeah, so I have already started all the routers, so those are all now up. Let me take um, mm, the console sessions of these routers. Let me this one. So let me show you the interface IP address. So IP, I'll send it for all the sessions. So IP interface brief. Let me So when I enter show IP interface brief on all the routers, you can see router 1, 12.1, 13.1. So it is connected to router 2, router 3, router 4, and router 7. Okay, and have taken the loopback interface as 1.1.1 and loopback 2 as 11.11.11. Okay, so I have configured loopback 10 as 10.1.1, so which is we are using for IBGP using loopback, so that I'll explain laterwards. Okay, so in each router you can see the interface IP address what I configured. Fine. So in this tab lab, so our motto is legenda is I'll explain. So BGP we are using for interface communication. That means AS to AS communication. Okay, and so there are two flavors like IMBGP and EBGP. So IBGP we are using for internal BGP. I mean within the same autonomous systems. IBGP is for internal autonomous systems. You can mention AS, and EBGP and EBGP for communication between the different autonomous systems. Okay, so we'll go for the BGP configuration part. Let me go to the router one, and if I want to show you to run section BGP, you can see here I have configured the BGP part in router one like router BGP 123, a network advertised 1.1.1, and I have advertised 11.11.11. So these are my neighbors. So this is my IBGP neighbor, and for configuring the IBGP neighbor, I have to mention the update source as loopback 10, and I'll tell about why we configure the next upself. So, and my EBGP neighbors are router 4 and router 7. Fine. So if I go to the router 2, so if I see here show run section BGP, in a similar way I have configured the neighbor peer group actually. So here I configured the peer group. So to configure the route reflectors. So why I have used the route reflectors, I'll tell in the upcoming sessions. Okay, so here my um, 10.1.1 be the IBGP peer, and 10.3.3.3. So that is router 3 is another IGP peer. Okay, and this is my external EBGP, that is router 5, which is the run autonomous systems 500. Okay, so In similar way, if I show you the router configuration in router 3, so they're also the same. So here my 10.2.2.2, which is my um, IBGP peer, that is router 2, and I have mentioned the update source as loopback 10. Okay, and my neighbor uh, another is router 6 and router 7, which are the eBGP peers and autonomous system 600 and 700. Fine, so let me show the configuration part on router 4. So if we show run section BGP, this router 4 is my uh, another is router, that means router R4 is an autonomous system 400, and I have advertised the network like 4.4.4 and 44.44.44, and yeah, this just ignore this command. Actually, initially I tried to configure by using redistribution, so without any BGP. So if you want, I'll remove this part. No redistribute. Sorry, I have to go to the router. Sorry, router BGP 400 and no redistribute connected. You want to copy this again? No redistribute. Okay, I'll make configuration saved. Okay, so similar way, if I go to the router 5, you can see here your run section BGP, your run pipeline section BGP. Fine, so router 5 is my another BGP pair, which is an autonomous systems 500, and have advertised this 5.5.5 and 55.55.55 in the BGP, and it is having only one neighbor, that is router 2. Okay, if I mm, let me show the configuration part in router 6, so run section BGP. Here you can see router 6 is having two neighbors. So one is router 3, which is in autonomous system 123, where it is an IBGP we are configured, and another router 7, which is an autonomous system 700. Fine, so let me configure router 7. Let me show the configuration part in router 7. Fine, you can see here there are router 7 having uh, four routers in neighbor. So those are router 1, which is an autonomous system 123, router 3 is 123, router 4, router 6. Okay, so I'll tell you why we configured the maximum path later sections. So this is, and even I advertise it uh, the network 7.7.7 and the network 77.77.77 in the BGP. Fine. So let me go to the router 5, which is, I'll do one thing, I'll take the screenshot of these. Easy for us to refer for. Okay, so let me summarize what we have did so far. So, so this is configured in single autonomous system, that is we configured IBGP here, and in between these routers and these routers we configured different A's. So yeah, we configured as an eBGP here as well as here. Okay, so the our BGP configuration part we have already seen just now. So let me jump into the concepts one by one. Okay, fine. So and now we'll learn about the show IPBGP summary and show IPBGP. So IPBGP summary will it will gives us the connected neighbor states, NEI states plus uptime of the neighbor. I'll write it down in the next line. It gives us the uptime of the neighbor. Okay, and number of the prefix, it is learning from the neighbor. Fine, and coming to the show IPBGP, it will gives us entire BGP table, what means the all possible ways to reach the destination via different available paths. Okay, so we'll see this in the BGP table. So let me go to the console session of our routers. So let me type here show IPBGP summary. So the router R1 is having uh, three neighbors. Let me show you that in this. So here the router 1 is having neighbor with R4, R3 and R7, right? 1, 2, 3, 400 and 700. Fine. And if you can see number of prefix it is learning, you can see the uptime. The uptime of the neighbor is 24 minutes and this is 24 minutes, 24 minutes, and the number of prefixes received as 8, 12, 12. Fine. if I let me clear out this and yeah, so let me go to here, show IP BGP. Then you can see here. I'll do one thing. I'll mention only show IP BGP include 10.2.2.2. So you can see how many prefixes it is receiving. So this is the router 2's and this is the router 5's and this is router 2 again and router 5. And fine. So actually this is the next hop and you can see mm, so as I told, if we go to show IP BGP, it will give the entire BGP table for reaching the destination with all the possible ways available in the routing in the BGP table. So if you want to show IP route, it will give the best routes available uh, in the routing table to reach the particular destination. Okay, if we can see the router 2 is via 10.2.2 and router 3 at 10.3.3. This is the loopback interface of router 3. Let me fine. So yeah, next topic is path. So is path is for best I can say for choosing the best path and is also for loop avoidance. So how it is avoid means if it says phone is number in the received route, then it will drop that packet or route. And so let's we have to see the ACE pass in routing table. I go to the router 1 to IP BGP. So you can see here this is the ACE path. Okay, and for example, if I take router 4, okay, if I take router 4 is here. So I'm checking. So I'm here and I'm checking the PGP table on router 1. Okay, so this route 4.4.4 is learning from that autonomous system 400. So that is just this one. Okay, and another route is learning from in this direction. that is 700 and 400. You can see here 700, 400. So whatever the route is traveling from autonomous systems to autonomous systems, it will append its own AS number to the route. You can see here it is appended the AS700. The route is learning from router 7. That means it is learning from this router is learning from router 4, and it will append this autonomous system and it will advertise to router 1 with his own autonomous systems like this. Okay, if I take another example like 6, 6 is learning from, you can see this is the 6. So R1 it is learning from uh, direct this one. So this is learning from R3 by IBGP. You can see here. Okay, so and one more path is like 700, 600, 700, 600. You can see 700, 100, and another is 400, 700, 600. So in this direction, one, and this direction two, and this direction three. See here, there are one, two, three. So three ways it is learning the route. Okay. So this is the ACE path. And next we will see about the origin code. So origin code is like we'll mention I E and question mark. So that means I is the route learning from network command, and E is learning from external, but it's not much using. And the question routes are learning from the grid distributed routes. Okay, let me do that in so you can see here the router 4 is redistributed, and we'll learn these routes as redistributed routes. You can see actually I removed that configuration in the beginning, so run section BGP. Initially, so I told redistribute connected. Okay, so here the connecteds are loopback 11, 12, 13, 14. So these are redistributing to into our BGP table. So when it is redistributing in BGP, the R1 is learning as so IP BGP So the R1 is learning these routes as question mark. Okay, and coming to the I, you can see here these are learned with network command, advertising that routes into the BGP using network, right? If you want me to show that, let me go to the router and I'll show you. See here, the router uh, 4 advertised that routes 4.4 and 44.4 using network command. Okay, you can see here the 4.4 is learning via I origin code. Okay, so the mm, mm, you can consider the best is I is better than E is better than redistributed routes. So this is about the origin code. Fine. So our next concept is next hop self. So why we are using next hop self means if any IBGP peer is learned the routes from EBGP peer, then then I can say uh, when that learned route is advertising to its another IBGP peer, it will not change its next hop to that IBGP route. Let me explain in the configuration part. So if I go to the router 2, okay, so actually, okay, so if I take this topology, so this is my IBGP dynamo systems, and when, for example, the 4 network 4 dot and 44 dot network is advertised and learned by router 1, so it sees then reaching to 4.4.4 and 44.44.44 by the next hop as 14.4. So that is this interface of router 4. Okay, and that route when it advertising to another IBGP pair, so that is router 2. So when it is advertising to router 2, okay, so I'll so this router 2 sees that 4.4.4 the routing table of router 2 with next hop as 14.4. So this neighbor. right? So this router doesn't know how to reach this interface. That means the AS400 uh, router 4 interface. So and it will not uh, able to reach this network via BGP. So for that reason, we are using next hop self. So let me simulate that in our topology. Let me clear all these things and then we will move on to our topology. Fine. So you can see the router 4 your instruction BGP. So have advertised router 4.4.4 and 44.44.44 in the BGP, and I'll remove the next hop self command. I'll remove the next hop self command router 1. Okay. See here I mentioned the router 2 that whenever you are going somewhere you have to reach me as my next hop, as your next hop. Okay. So let me remove this part router BGP 123. So now neighbor of self. So I'll do clear IPBGP start soft, and I'll clear here clear IPBGP start soft. Okay, so let me see show IP BGP. Can see here the router 4 is learning the routes from 192.1.14.4. Okay, and the other one is learning from the IBGP from the router 7. You can see that actually configured, so that's why you're getting confusion here. So this router 2 is learning from here like this. Okay, so as this router is configured as an IBGP, so it is learning this route, but in general you can see the other path as 14.4. Okay, let me let me ping that 4.4.4 source 5.4.4, sorry 2.2.2 is pinging, and if I want to restart that, it will reach via R3, not R2. Source 2.2.2. So you can see here it is reaching to router 3, and from there router 7, and from there router 4, this way router 3, router 7, and from there it is reaching to router 4. Okay, how it is taking the path. So I removed that next hop from router 1. So that's why this router is not, even though it is learning the routes from router 1, but it is not taking this path. Traffic is not taking this path. So let me add it back the route. Let me add it back the next hop self. Okay, so if I go here, router 1, and I'll mention neighbor 2.2.2 next hop self. Okay, I'll clear the PG table once. IP source off, and I'll clear the BGP table in. Okay, so if I see show IP BGP, still learning as the BGP slow routing protocol. Let's see it again. Not at land again. Learning. Okay, you can see here it is now learning from 10.1.1. So let me not sure why it's not learning other routes, but okay, quickly. So now if I ping 4.4.4 from the source interface of back to back, it is pinging, and if I do the trace route to 4.4.4 with source 2.2.2, you can see here now it is reaching to router 1 and then router 4. You can see here. So this router now reaching to this 4, that is router 1 and then router 4. Yes, this about the next hop self. And in next hop self, you can see here I removed the BGP peer group means route reflector configuration from R2 between R1 and R3. So I just directly configured as neighbor 10.1.1 as my remote is 123 and 10.1.1 or 10.3.3 as my remote is 123. So even if I can go and see in router 1, so and meanwhile let me take a look at router 3 also, show IPv, and you can see here I mentioned 10.2.2 has my next hop self. Okay, and even router 3 I mentioned 10.2.2 as my next hop self, and when comes to router 1 2, so I didn't mention that whenever it is advertising uh, to its eBGP pair, maybe it is not updated the next hop self. Okay, if I go to there and if I see to reach 4.4, it is learning from its neighbor part Okay, so I will do one thing and let me add that next up self router BGP 123 router BGP router BGP 123 neighbor. I'll copy this neighbor 13 I mention next up self because I couldn't able to reach from R5 to R4. If you can see, I'm just trying to ping, but ping is not responding, as well as I'm doing trace route also, it's not working. And so I'm expecting maybe the IBGP next up self. So let me configure that. Okay, so I've added this one and let me add neighbor as my next up self. Okay, here I will do and here BBG star. So do in router 5 here BBG star sub. Okay, let me see the BGP table again. Yeah, I'm learning the routes and let me try it. Ping 4.4.4 my source interface as loopback. Sorry, yes. So can identify the issue now. If I go to the trace route 4.4 from the source 5.5, yes, now been able to see if the traffic is reaching to R4 via R2, R1 and R4 is R2, R1 and R4. Let me try to reach this network via R5. So let me trace to 707. So as you can see, it is reaching to R2 or it's reaching to R2 and R2 R1 and R7. Earlier, I just missed uh, here saying that this R1 as my next hop means 10.1.1.1 is my next hop self and saying R3 also to reach R5 I mean R3 with my next hop self here. Okay, so fine. Fine. Our next topic is BGP split horizon. So this is for loop avoidance in IBGP. How it will do means whenever it sees its own is, then it will not advertise that route to its any other neighbor. Okay, so I can say, for example, in the same autonomous systems, for example, ACE 123 R1 routes length by R2 and it will not give those to R3 and in vice versa also. Yeah, so whatever the routes line from the router 1, okay, by router 2 will not send those routes to uh, router 3. I can say that let me go to the configuration part and we'll see. So I'm in router 2 now. So let me see here. So IP BGP table. You can see here it is learning the route 1 as well as router 3, right? These three, sorry, these two prefixes are there. That means the routes are there for 1 and 3. You can see the next stop is router 1 and router 3. So let me go to the router 1 and if you can see show IP BGP table there, I can't see any router 3, I mean route 3, get it? So this is because of um, so BGP split horizon rule to avoid the loop. Okay, so how we can overcome this issue? So to overcome this issue, we can use we can use uh, I can use that full mesh. That means every router is neighbor of other router, or we can use or we can use RR. So that is nothing but route reflector. Fine. So here this full mesh is having some limitations, right? So for one or two routers is easy to configure, easy it's easy to configure full mesh, but if you can consider more than 100 or more than 3 or 4 routers, more than 100 routers, let's say it's very difficult, right? It is very difficult to configure full mesh, right? So you want I'll show you example. In our topology we have these three routes, right? So configuring full mesh means uh, this is router 1, this is router 2 and this is router 3. Configuring full mesh, I have to configure router 1 saying that router 2 is my neighbor and router 2 I have to say that router 3 is my neighbor and router 3 I have to say router 2 is my neighbor and router 1 is neighbor and router 1 I have to say router 3 is my neighbor. So like this I have to configure for full mesh, correct? So these are not scalable solutions, right? Scalability issues if I have more number of routers, right? I like this kind of routers. How can I do? So, right, I have to say all the routers that this your neighbor, so this is your neighbor, this neighbor. So this is total mess kind of right. All right. This is not scalable solution. So we'll use we'll use the route reflector. So most of the cases in the data center setups, so we are using route reflectors instead of full mesh. Okay, so anyway, so in our lab topology, we will configure both uh, the configurations and we will test that. Okay, so let's jump into our lab. Fine, so yep, so I want to say here I mentioned show IP BGP. I'll do show run section BGP and see, as of now I have mentioned only router 2 as my neighbor, so let me add the router 1 also in the configuration. So I'll do, let me open this and I'll say copy, so I'll take here 1.1.1 1.1.1 and I'll say 1.1.1 and in router 3 also I have to configure router 3.3 as so 3.3.3 and 3.3.3. Okay, so this my router 1 configuration part. Let me go into configuration part, router BGP 1 to 3, and I have to paste that. Paste. Okay, so in a similar way, I have to go to router 3 and I'll router BGP 1 to 3 and I'll paste this router 1 part. Okay, fine. So let me do clear IPBGP store soft and we'll check. Let me clear IPBGP, sorry, clear IP store soft and let me do it in router 2 also. So clear, do, can see here, do clear IPBGP store soft. You can see here the router 1 neighbor came up. So if I go and see do show IP BGP, you can see here now the routes are learning by our router 1, right? So if I want to ping the routes, sorry, ping 3.3.3, so 1.1.1 can able to reach. And if I go to see the trace route 3.3.3 and source from 1.1.1, yes, it's reaching via direct connected interface, right? So that's fine. In the same way, I go to see in the router, show IP BGP, You can see here router 3 also learning the one routes from router 1. Okay, can able to ping source from 3.3, right? So fine. Fine. So as of now, we have seen full mesh configuration topology. Fine. So moving on to our next topic is route reflector. So this is uh, to configure uh, provide this BGP split horizontal. Okay. So uh, uh, in RR, so what we will do before configuring the RR, we have to learn about peer group. So peer group is nothing but just a defining similar kind of parameters in a group, right? You can see here, you can see here for saying neighbor 10.10.1, 10.10.10.1 as remote is updates was to back next up self and again router 3. So if I paste this in router 2, so it will be total 6 lines, right? So instead of making these 6 lines, I'll use a peer group and saying that to and saying that uh, that peer group having similar kind of properties. Like so, let me take this as I'll tell uh, I'll take this and I'll mention here that neighbor 10.10.10. So that I'll say neighbor ABC, remote AS122 and neighbor ABC 122 and neighbor ABC next up self, and before going that I'll say neighbor ABC is a peer group. Okay, peer. Okay, so after that I have to say neighbor 10.1.1 peer group ABC. Similar way I have to say neighbor 10.3 peer group ABC, right? So right, so let me go to the configuration part and let me remove that full mesh configuration. So no all show route BGP. Okay, so router BGP 123. I'll remove I'll remove this part. No number. No number updates. X0. No stop self. Okay. So do show run section BGP. Now I removed 10.3.3 as my peer group. So let's go run section. I want to remove that here also. section BGP, and I'll go conft router BGP to 3. Okay, so no. I'll tell 10.1 right. So number, that's it. Do show run in BGP. Now that's all. Let me do show IP BGP. Should not be have that router right. So there is no any route belongs to router 3. And do show IP BGP. We should not have route 1 routes right. There is no routes. So let me configure BGP group here. Some route reflector here. So I'll do uh, I'll remove when the BGP neighbors. So when section BGP that I'll remove both of this 1 and 3 as my next up self in BGP peer. What happened? Configure T router BGP 1 to 3. No. No. 10.3.3. Correct. So do clear IP BGP star soft. I'll do it in router 1 also do stuff that I'll mention end clear IP BGP star soft. Okay, now we'll move on to router 2 for configuring the peer routes. So configure T router 1 to 3. Sorry, router BGP 1 to 3. Sorry, router BGP 1 to 3. Neighbor ABC is my peer group. Okay, and neighbor ABC remote is will be 1 to 3, and I'll say remote ABC updates update source loop back 10. Neighbor ABC also next up self, and neighbor 10.1.1.1 peer group ABC. And similar way I have to tell router 3 also my peer group member. Correct. You can see here now I got 10.1.1 and 10.3.3. And so show IP BGP, sorry, show IP BGP summary. I can see the route 1 and 3 become my peer groups, and I'm receiving some of the routes, right? But if you can see here, show IP BGP summary. So still I have only one neighbor. There is no router, 3 neighbor in my routing table from BGP. So even if I can see show IP BGP, there is no 3 route. So we are not yet configured route reflector. So here I'll say here neighbor ABC as my route reflector client. So that I'll mention here in router 2 saying that my router 1 saying that in router 2 I'm saying that router 1 is your route reflector client and router 3 is your route reflector client. So that I'll and so okay I'll say here neighbor ABC route reflector client. That's it. Now you can see now BGP neighbors went down and it came up. That means our route reflectors are converged. Let me show IP BGP do show IP BGP. Somebody, yeah, I have two neighbors, and if I go to scene, let me see the summary. I haven't received, then it's not the neighbor, but let me see. Okay, you can see here I have received our routes belongs to router 3, 3.3, 33.3 as my neighbor is 10.3.3. Okay, so if I ping 3.3.3 source 1.1.1 ping, and if I go to trace dot 3.3.3 from source 1.1. Yes, can see can able to reach via R3 interface, right? So that means my control plane traffic is going through R2. That means R2 is decided the control traffic. Like I can say this R2 is my control plane, correct? So what it does saying that for reaching to R3 from R1, you have to reach this interface, right? So there is no any role in data plane traffic reaching from R1 to R3. Correct? The traffic is directly reaching to this R3. It's not reaching over, I mean not reaching via R2, but the control plane is reaching via R2. So data plane is just skipping that R2 next stops. You can see here directly reaching to R3 next stop, not taking R2 path, not going via R2. So this is the route reflectors. Okay, thanks for your time. So we'll have another session for other topics in BGP to cover up. Thanks for your time.